Okay, now we have seen how to write a program to find the sum of the individual digits of the number. I'll just throw these programs to you on the screen, take few seconds to have a look at it, and then I'll copy these statements into the Microsoft Word and tell you the meaning of these programs. Okay, so let's try to understand the what exactly you mean by the programs all the way from 3 to 8. The first program is find the total number of digits in the given number, right? So slightly different than the program in terms of finding the sum of the individual digits of the number. So if the input is 456, then the output should be 3. The total number of digits in the number 456 is 3, 4, 5 and 6. So that's the meaning of it. A small change in the body of the while loop of the previous program will help you to get the output of this particular program. We have something called as find the occurrence of a particular digit in the given number. So say for example, if your number is 4552 and the digit is equal to 5, then you say that digit 5 occurs 2 times in 4552. So that's the meaning of what you mean occurrence of a particular digit in the given number. Then you have the next program, what is called as find the reverse of the number. I don't think much I have to tell you. Suppose if the given number is 456, then its reverse is 654, right? So let us try to understand the program for reversing a given number, and then we'll come back to the other programs called as palindrome numbers, Armstrong numbers and Russian pigeon method. So as usual, let us not bother about the syntax. I have 456 as the number and the reverse is 654. So as usual, what you do is you have your declaration statement, you have your input statement, printf, as well as you have your input and output statement, both printf and scanf. So I say printf, enter the number, and then you say scanf %d, and then you have your number. So I have my number as 456. Now this is my number, right? And reverse I'll take care afterwards. So what I do is, as usual, I have my while loop, and then I will not write the condition for the while loop. I will take a call on this later. And then what I'll say is, I will say digit is equal to num %10, which resembles exactly what we did for the sum of the number, right? So digit is equal to num %10. So currently my value of digit will be 6, right? Now what I am going to do is, now this is a logic from the digit 6 is in units place and the digit 5 is in the tens place and digit 4 is in the hundreds place. So when you migrate from digit in units place to a digit in the tens place, you actually multiply it by 10. Similarly, when you migrate from digit in the units place to the digit in the hundredth place, you again migrate from 10. That means when you shift from right to left, in the sense when you are facing the number, when you shift from right to left, every step is actually a multiplication of 10. And keeping this particular logic in mind, what I do is I introduce a new variable called as reverse, and I will say reverse is nothing but reverse multiplied by 10 plus digit. Now what happens, my I initialize the variable reverse is equal to 0, and then now what happens is when the control comes to this particular line, the value of reverse is 0. 0 into 10 is 0 plus digit, which will be 6. So the value of reverse is equal to 6, and then I divide my number by 10, correct? And then I have my closing loop. Now the value of num becomes how much? 456 divided by 10, my num becomes 45. And as usual, I go back to the while loop bracket and then I say while num not equal to 0. So now my value of num is 45, 45 not equal to 0, condition is satisfied. I go inside the loop and now my digit is equal to num percentage 10, num is 45, so my digit becomes 5. Right? And then when the control comes to this line, my reverse REV is actually 6. 6 into 10 becomes 60. Watch out carefully. 6 into 10 becomes 60 and plus digit. So my reverse becomes 60 plus 5, 65. And then num by 10, num becomes 4. 45 by 10, it becomes 4. Now control again goes back to the beginning of the loop. And I have my value of num as 4, 4 not equal to 0, my digit becomes 4, right? Now reverse is 65, 65 into 10 is 650, 650 plus 4 is 654, and num by 10, 4 divided by 10 is 0. Again control goes back to the beginning of the loop, 0 not equal to 0, condition is false, come out of the loop, and then you print the value of variable reverse, which is nothing but 654, and hence reverse of 456 is 654. Now this is the logic behind the entire program of reversing a given number. Now keeping this logic in mind, I want to think on the program which is there down, what is called as check whether the number is palindrome or not, right? The initial portion of this program is exactly same. You need to find out the reverse of a number, and then if the original number is same as the reversed number, the number is called as palindrome. For example, if you enter a number 456, right? If you enter a number 456, its reverse is 654, which is not same, so this number is not a palindrome number. Please understand, right? So a number is called as a palindrome only when the reverse of the original number is same as original number. Say for example 121, its reverse is also 121, so 121 is a palindrome number, right? So keep this in mind and develop a program for checking whether the number is palindrome or not, because this particular program is also a part of your lab program. Let us move into two other programs which are not there in your syllabus, but I would strongly urge you to do the program on your own. I'll tell you the logic behind it. That will improve your not only logical skills, but also it will improve your programming skills. Now the first one is display Armstrong numbers. Okay, understand the definition of Armstrong numbers. Armstrong numbers are defined as sum of cube of individual digits of the number. I repeat, sum of cube of individual digits of the number equaling the number itself, right? Watch out carefully. Sum of cube of individual digits of the number equaling the number itself. Such type of numbers are called as Armstrong numbers. Let me give you an example. Say for example, I have a number called as 153. Watch out carefully. I have a number called as 153. Now what it says, sum of cube of individual digits, right? Let me extract individual digits of this number 153. So I will write it like this. What are the individual digits? 1, 5 and 3. Let me write it like this. Some individual digits, right? 1, 5 and 3. Look at the first part of the definition. Sum of. So I will add the operator plus in between the digits. So this is called as sum of. Understand? This is called as sum of individual digits. What it says? Sum of cube of. Cube. So let me put it. Give me some time. Now watch out carefully, right? Armstrong number, sum of, this is the sum of, cube of, this is cube, raised to the power of 3, cube of individual digits 1, 5 and 3. So, sum of cube of individual digits of the number equaling the number itself. Such type of numbers are called as Armstrong numbers. Let us see this. What is 1 cube? 1 cube is 1, right? Then what is 5 cube? 5 cube is 125 and 3 cube is 27. Now add up 125 and 27. How much it comes? Correct. It comes to be 153. Am I right? So this 153, when you do this particular arithmetic operation, is equal to this number, and hence 153 is termed as Armstrong number. So what you have to do is, you are supposed to display the Armstrong numbers. You are not supposed to check whether the number is Armstrong or not. There are two different versions of the same application. One, you are displaying all numbers which are called as Armstrong numbers, where there is no limit for you. On the other hand, if you say you are going to check whether the number is Armstrong or not, then you need to have a input statement which will input the number which you want to find whether it's Armstrong or not, right? So my suggestion would be, when you are trying to go for this type of application which helps you to display the Armstrong number, maybe what you can do is, to start off, you write a program which will display Armstrong numbers from 1 to 1000. That's it. So you can have a loop which starts from 1 and goes all the way till 1000, and once the program comes out of the loop, it will print certain numbers, and those numbers are actually Armstrong numbers, right? For your convenience, when you write a program up to 1000, you should get these numbers as Armstrong numbers. The first Armstrong number is 1. You do not have any Armstrong number from 2 to 152, and hence the second Armstrong number is 153. You can check it out. There is no number from 2 to 152 which is called as Armstrong number, and hence after 1 the next Armstrong number is 153. After 153 the next Armstrong number is 370, because 370 is nothing but 3 cube plus 7 cube plus 0 cube. Common sense tells the next Armstrong number is 371, and the last Armstrong number is 407. 4 cube plus 0 cube plus 7 cube is 407. Believe me, in the first 1000 numbers, there are only 5 numbers which are called as Armstrong numbers. I want you people to develop a program for this and not just print these 5 numbers, because I know all my classmates are Nobel Prize winners. I do not want you to print these numbers. I want you to write a program which will display these numbers. Am I clear? Good. Let us go to the last program. Beautiful program this is actually. Don't worry about the wordings of it. It looks like, don't think that the program comes from Russia or something, right? It is actually called as Russian peasant method. The problem statement is like this. You are supposed to write a C program which will multiply two numbers using Russian peasant method. I repeat, C program to multiply two numbers using Russian peasant method. Let us see how this particular program works. Okay, so what we do is we enter two numbers, we call it as num1 and num2, right? And then let us have two numbers, let us say, what should I say? I just say 26 and 12, okay? Now these are my two numbers. 26 is my first number and 12 is my second number. So what is the product of this? 26 and 12 is how much? 260 plus 52, so the answer is 312, correct? I'm just writing it for our reference, that's all, nothing to do with the program as such. Now, so these are the two numbers that are given to us. We need to find out the multiplication of these two numbers using Russian peasant method, right? Now, understand the logic, very simple. The first step is divide the first number by 2. Please understand, divide the first number by 2. What is the first number? 26. Divide 26 by 2, which is 13. Understood? Now when you divide the first number by 2, you write the result below the first number. Write 13 below 26. And simultaneously you multiply the second number by 2, that is 12 multiplied by 2, which is nothing but 24. You got it? Did you understand how did I get 13 and 24? I repeat, divide the first number by 26, write it below that, multiply the second number by 12, write it below that. That is how I get 13 and 24. Now, what you have to do is, you have to do this particular task. That is why this comes as an application of loop control structures. Keep on dividing the first number by 2 and simultaneously multiply the second number by 2 till the first number reaches 0. Please understand. Till the first number reaches 0, you have to do this task of dividing as well as multiplying the second number. Let us proceed. 13 divided by 2 is how much? No, not 6.5. 13 is integer. So integer operated on integer will give you integer. So 13 by 2 is 6 and 24 multiplied by 2 is 48. 6 divided by 2 is 3 and 48 multiplied by 2 is 96. 3 divided by 2 is 1. And 96 multiplied by 2 is 192, right? You can skip the last one because 1 divided by 2 is 0, so you can go up to 1. So keep on dividing the first number by 2 and multiply the second number by 2 till the first number reaches 1, right? Now this is where your division and multiplication arithmetic operation gets completed. Now once you get this, what you have to do is, you have to add the second column numbers. Be careful, you have to add the second column numbers where the first column is odd. I repeat, you have to add this particular column numbers where this particular column is odd. Now, Is 1 odd? Yes. So put 1 plus sign here. Put 1 plus sign here. Is 3 odd? Yes. So put 1 plus sign. Is 6 odd? No. So don't write anything here. Is 13 odd? Yes. Put 1 plus sign. Now what you have to do is, you have to add this 24, 96 and 192. So how much? 4 plus 6, 10 plus 2 is 12. So carry 1, 1 plus 2 is 3, 3 plus 9 is 12, 12 plus 9 is 21. So this is 1 and 2. 2 carry plus 1 is 3. 3. So the product of 26 and 12 is 312. 312. So this is how Russian pigeon method works. Now, to all my great programmers in the class, if you are making an attempt to write this program, I am not that much interested in the output of your program. When I give the input to your program as 26 and 12, I want the output on your screen exactly how I have shown you here. Maybe you don't need to get the rectangle boxes. This is only for our convenience I have drawn. But I want the output exactly how I have written it on the screen. Means I should have 26 here. Right of 26 I should get 12. Below 26 I should get 13. Below 12 I should get 24. So 24 is below 12 and right of 13. And I should also get this plus on the right side of 24. So this entire stuff should be a part of your output. Otherwise, I know what you will do is, you will say scanf ampersand A ampersand B, and then you will say C is equal to A star B, and you will say printf product of A and B is C. Right? So only if you are able to show the output like this, it makes some sense. Okay? Great.